So we should be live now, or at least as close to live as we can be. And we're going to talk about mechanical integration. And Todd's here with me with some questions, and so we'll talk things over, and folks can watch it later. And if they want to join us the week after spring break, we'll be here doing it again. So then Brad should be back after that. But we were just talking about Todd's project, and he has a barn with a watering trough for horses, and you're thinking about putting in a PV system to run a heater.
Two different trough heaters.
Two different trough heaters and some lighting.
Three, four lights.
Okay.
Maybe plug-in.
And do you have any power there as is, or no? Okay. And then some of the factors to think about if you're looking at a PV system to do something like that is how far away the existing power is, because it can often be much less expensive to run an electric line, to run a circuit to the barn or to feed the barn from your existing source. So it's just something to consider, not to discourage.
Yeah, it is a fairly long distance, like probably well over 100 yards.
To over 100 yards.
Yeah.
So I would suggest you do that as part of your project as well. Maybe as the footnote or an afterward. Do the project, see what it's going to take for the solar to run, and you're looking at those critical design months of the winter months when you're going to need to keep the ice melted.
Yeah.
And then once you've figured out how big a battery bank and how large an array you're going to need, then you can kind of put some numbers as far as the cost and get a rough idea of how much that would cost. And then go back and say, okay, if I were to trench and bury a line from your existing house or service to that barn and feed it, how much would that cost, and what would you be looking at? So just to make the comparison, because and again, not to discourage solar, because I think it's great. It's just it has places that it works really well for systems like that, for a standalone type system, and other places that you might do better putting in the line from your existing service and then putting on a really small grid-tied setup that would, you might wind up coming out cheaper that way, and you still be including solar.
Then you're paying monthly fee to the power company versus...
Well, and it depends on your utility. The different utilities have different requirements in terms of interconnection agreements, and so that's something to look into too. If you're going to do a grid-tied system, you need to check with your utility and see what they require for.
But
if they charge you a monthly fee, or if there's no fee associated with it, or often.
I wouldn't. If I was going to grid tie it, then I wouldn't do both.
You wouldn't do both. Okay.
I was just thinking it would take, probably one panel and fairly inexpensive converter.
Well, you can just go through the system sizing and design exercise and see.
Do that.
Yeah.
Okay.
And you could consult with Brad, but I think that would be adequate for the project to go through that process
so
of designing.
Need to know the watts that the heaters are pulling, right?
Yeah. So you need to know what your loads are in terms of the heaters and any additional, if you want to do lighting or anything.
Yeah, the lighting would just be, probably these LED lights. So
yeah. And then you need to look at what your solar resource is going to be during the months of highest use for the system. So, and unfortunately, with a system like that, you're going to need the most energy to keep the ice melted when you have the least sunk. So,
Yeah.
so that'll be a test. And then the other thing to think about with something like that is, well, what about in the summer when I really don't need power at all in a case like that?
Uh-huh.
You know, you've got the generating potential. So that's why it would be nice to have it grid tied if you were thinking about something like that.
Right.
But again, I don't want to discourage you.
Uh-huh.
Explore it and see what you find out. And,
Yeah.
yeah. See
Okay.
what it would do. So, we can talk a little about the mechanical integration side of things. The reason we got on that topic this morning was because you were talking about mounting the panels on the barn or on a pole, or trying to figure something out because you have a east-west facing roof,
Mhm.
right?
Yeah,
And
it's
so-
heat, so I'm guessing that by the time you bought all the different hardware to make the panels face south on the rooftop like that, would be
Yeah.
expensive.
Yeah, if you mount the panels on a steep east or west facing roof, then it really reduces the performance a lot. And then if you tilt them way up, then they, one, look funny, and two, you have the added cost of the hardware and so forth. So one of the thoughts that I had was looking at, I don't know if we can see the board up there very well. The projector's pink today. But on the screen here, we've got two wall-mounted panels, and so that's an option. You can, I don't know if you can see the framework underneath, but then it has kind of braces that push the bottom of the panel out, and you can mount them on a wall in that way.
Yeah.
And those are often adjustable, so you can swing the bottom out and so forth. And one that I'm working on right now, for a very small off-grid system, we're going to do just this type of thing and mount them on the wall of an outhouse, because the outhouse is in the sunniest spot on the property, so we'll put it on there. So, yeah. So, let's see, the other image we had was the actual framework. Let's see if we have that. And so the framework looks something like that. You can imagine the panel mounted on it. So. Which brings us, when we're looking at both designing the system, if we're doing a site evaluation, we're gathering the info about the roof and stuff, as well as when we're mounting the panels. One of the tools that's really handy is the angle finder there. And this you can just lay on the roof, and it'll tell you what the pitch of the roof is, or the angle of the roof. And that's helpful because a lot of times drawings or architectural drawings or plans will have the pitch relative to 12, 3 and 12, 4 and 12, 10, 12, that kind of thing. And so you can convert it, certainly, to an angle. But I like to just have an angle finder in my kit when I go out, and I can just stick it up there, and then I just read the angle off of it, and I don't need to worry about doing the calculation and have it right. And you guys, have you talked about the Solar Pathfinder or the other types of tools like that? So those are great in calculating shading and figuring out what your performance will be.
In my case, shade is not a problem. It sticks out, it's sitting out in the middle.
Yeah. And that's great. With yours, you talked about the alternative of mounting on a pole. My preference, personal preference, and it is just a personal preference, is using existing structures. If you have an existing structure, that's what I tend to lean toward. Yeah, if it's structurally adequate to hold it. Otherwise, if you start putting in a pole mount for a couple of panels like that, you've got a more elaborate mount, because the mount would have to connect to a single pole. And so the mounting is a bit more expensive. Plus, you've got to plant a hole in the ground. You've got to put it in another chore and added expense.
So, like, if it just ended up being one panel,
Mm-hmm.
you couldn't just take like a L-shaped, J-shaped bar that would bolt to the side of the back side of the barn, and then just come up, stick above the roof, and then you just mount that one panel.
So mounting it such that it sticks above the roof, I would tend to avoid.
It's just because of the wind situation.
Yeah, because of the wind, you might gain a little bit in terms of, not being shaded by the eaves or something like that. But, yeah, if you get it up above one, it's, I think, not aesthetically
Yeah.
as appealing, and then also, if you get it up in the wind, if there is wind, then it might tend to vibrate or shake or that kind of thing. So structurally, you have a lot more to worry about if you're bringing it up above.
Versus having a panel bolted down on all
Yeah,
these edges.
with that other image, you would basically bolt a hinge type attachment to the wall, connect the panel to it, and then swing the bottom out and just have a brace.
Okay.
So you have really solid attachments
Yeah.
to hold it. And, and you can, if you wanted to extend the whole thing out a little bit, if you're trying to get clear of eaves or something like that. So. Yeah, and in the winter, your sun's going to be really low, so it likely wouldn't have as much effect. In the summer, when it's high, you might lose a little bit early and late in the day, but So, this article that's posted there on the class site just kind of goes through the different tools that you might need, might use on the job, and I won't go through every one. I will say some of my favorites. We have all the tools for assembling and so forth, the wrenches and drivers, drills and things, but the angle finder is really important, and you wouldn't find it as commonly in other trades, but we use a lot because we need to know, the slope of the roof, the slope of the panels when we're installing them, and that can make a big difference in the performance of a system. So it's important to know and use the Solar Pathfinder or something similar, a tool to calculate the effects of shading and to figure out, if you have a good site, or if you're going to be really limited by the shading or orientation. Let's see, what else? A lot of standard tools. The crimpers. If you're doing off-grid systems and you're building your own battery cables, then commonly we'll use the crimping tools to crimp the lugs on the ends of the cables. So a lot of times it's more conventional now, it seems, to buy pre-made cables. But if you are making your own, then you'll get to know the crimping tools pretty well. They're not as common as other things. And then meters are really important, and we'll get more into meters with the electrical integration side. But both a voltmeter and a amp meter or a clamp meter are going to be really important to measuring the output of the system and making sure it's performing as it should.
But that one does both, right?
This one does both, and you could get one that does both. I have two separate meters. When I looked into a meter like this, to get one that did both was more expensive than to get two that were specialized.
Okay.
So, but times change, tools change, technology changes. So, it's worth shopping to find what you want. And also, when talking about meters, I think we might be talking about electrical the week after spring break. Yep. So we can talk a little more about that, but making sure that the meter does what you want it to do. When we're looking at the clamp meters, we're often looking at high voltage DC, and many of the just standard clamp meters that you would get at your electrical supply stores they'll go up to, say, 300 volts AC or 500 volts AC, but they might not do the same for DC. So you have to look and make sure that the meter does do the jobs that you need it to do. And then the other thing is, when we're looking at meters, we'll often want things that we can work on smaller circuits with and measure very small levels of current. So if you can get something that works at both ends, something that works at 5 volts DC and can give you milliamp readings, but then also at 500 volts DC and give you larger amperage readings. And again, it depends on what you're doing. If you're working on commercial, large-scale solar PV systems, you're probably going to have a meter specialized for that. And me being more budget-minded, and I don't do many large systems, I think a lot about, well, can I use this meter on both ends of the scale? What's the best meter for me? So I would suggest doing the same when you're looking at those tools. So let's see if we can get back to our class site, and we'll look at this. Yeah, so as you go through this chapter, you're going to see that mounting PV systems is a lot like putting together an erector set. They're pretty standard and straightforward. Most manufacturers have their own specific style and design, their own system, but in essence, most of them work the same way. I mean, the idea is you're attaching your solar modules together and to the roof, or you're putting them on a pole, so you're putting them on some sort of mounting system. Some of the things that we have to do, well, I'll kind of go through the book so I don't get sidetracked too much. As you work through, you'll see that leaving space under the modules is really important. When the performance of PV modules is improved as the temperature goes down, they become more efficient. You can get higher voltages at lower temperatures. So inversely, as the temperature goes up, the efficiency goes down. We in Montana have pretty good summer conditions because we have long, sunny summer days, and the temperatures are rather cool comparatively. If you're in Arizona and it's 120 degrees and your panels are sitting out in the sun cooking, then their efficiency is going to be far less than a similar situation here in Montana. They have more sunny days throughout the year, and their winters are probably more close to our summers, so they year-round have better performance. But in the summer, and you could do the comparison and look at performance here and there, but we may outpace them for summer performance. Interestingly enough, one of the things, so there are different ways to mount, and we talked about mounting on poles, we talked about mounting on the roof or on walls. Pole mounts don't really suffer from heating issues of trapped air behind them, but when we start mounting on the roof, we have to take that into consideration. Bill Brooks did a nice calculation. It's kind of an optimization, if you will, and he went through and demonstrated the ideal or the best air gap, or the minimum required air gap, if you will. How do I say that? Neither of those quite sums it up. Basically, the amount of space behind the panel that gave you the best cooling, and beyond which it wasn't necessary to go much further.
Oh, I see.
Yeah, and I don't have that in front of me, but I think it worked out to be about 3 inches was his, up to 3 inches you're still improving, but beyond 3 inches, you might improve a little bit, but not so much. So having them on 7-inch posts that keep it way off the roof will make it look funny more than it will help keep the panels cool. So, but if you just take them and bolt them flat to the roof or leave only a 1/2 inch gap, then they're definitely going to heat up and you're going to reduce the efficiency quite a bit. So maintaining that gap is important, and most of the commercial racking that you get is going to do that just by nature, because the way that the racking is constructed and so forth. But if you're thinking of doing something custom and going off on your own, and well, I'd like to just integrate this right into the roof, and I want it to be flush with the shingles or something, then you have to consider that what's going to do to your performance. And I mean, it could be done. Maybe you'd need to vent it somehow underneath, but again, now you're in the realm of custom design, and we're not really delving into that too much in this class. So, but things to think about. One of the other things that's neat about mounting solar arrays on the roof is that it protects the shingles, and typically the shingles that wear out the fastest are going to be the ones in the south face of the roof. So we've gone and removed solar arrays so the roof could be redone, because the shingles all around the edges of the array were cracking and splitting and crumbling, and the shingles underneath the array look brand new. So, most of the damage to the shingles is from the sun and the heat, and the solar panels above are giving that nice air gap where it keeps it cool and the air flowing, and so you don't have the wear on the shingles. So if you could somehow cover the entire south side of your roof with solar panels, then you would probably double the life of your shingles, or then you just be looking at the north side for when those are going to need to be replaced. So that's a neat side effect. In the past, there have been companies that have produced solar shingles or solar options for solar roofing. They're not as common anymore. I haven't been looking out for them recently, but I know there are some modules that are frameless that can be overlapped slightly and used in that capacity. There are other companies who make covers for the seams in between that can allow you to use a solar array as a roofing property, or a roofing structure, but usually more I've seen those in outdoor structures, pergolas and things, covering porches or the like, so that it's not crucial that it be waterproof. So again, I talked a little about tilt, and tilt is really crucial for performance. So looking at that, if the pitch of your roof is not great enough or is not ideal for your location, then it's worth going to something like PV Watts and just playing with the numbers a little bit and say, well, what if I tilt this thing 15 degrees more, or 20 degrees more, or 30 degrees more, is my performance going to improve that much? And I always like to do that and then say, okay, I'm going to produce this much more. How much is it going to cost me to do that? So then go back and look at the additional cost of the racking that would tilt it up and see how that compares to what you'd be gaining in performance. Because a lot of times you'll be surprised that tilting at another 20 degrees is not going to make much difference. So playing with those numbers a little bit to see what the improvement is.
And then in my case with that barn, if this was going to have a fixed rack that wouldn't move, I probably want to tilt it to whatever would be best in December and January.
Yeah, so when you're...
who cares in the summer because you're not using the power anyway.
Yeah, and when you're dealing with grid-tied systems, people don't usually adjust them seasonally because the performance gained from doing that is not significant, and it probably won't be worth the added effort. And some people set with at the beginning have the best intentions and start out. Some people may keep doing it, and more commonly, I think it just becomes a no. I think we'll just leave it as is. And again, with something like PV watts, you can do that calculation. You can compare. Okay, what if I put it at this angle for these 3 months? And you'd have to do it. You'd have to set your angle, run it, go to PV watts, and pull off your performance, your production numbers for the winter months when you'd have it at that angle. Go back, change your angle, and then see what the performance is for other times of the year. So if you just did a spring and a fall adjustment, you could look at PV watts at those two different angles and then see, write down your summer performance and your winter performance separately and then determine if it's worth it. And so I was going to say, grid-tied systems, it's not essential, and so it's less common. And so you will probably just find the best tilt for year-round performance and set it at that. If it's easy to adjust, then it might be something you do more commonly or that you keep doing. And then the other thing is if you have an off-grid system, you're going to want to get the absolute best performance in the winter that you can get, but you're still going to want to have the best you can get in the spring and fall also. And in the summer, you might not need as much power, and you've got more sun. So you might have two different angles. One is optimizing the winter, and then a little flatter to optimize spring and fall. And then you might not adjust it for summer, or you may, depending on what your loads and requirements are. Or if you have something you can do with that additional power if you're overproducing, or additional energy if you're overproducing in the summer. If you have it tied into a dump load and a water heater or something like that, then maybe it is worth making that adjustment. But off-grid is much more crucial, and when you're living with it, you'll do what it takes to make it work. So the wall-mounted systems, most of what I've seen are just a modified roof mounting rack. So many of the companies use the same roof mount rack, and they just have you turn it and mount it on the wall. So instead of tilting from the roof up toward the sun, you turn it around, mount it on the wall, and tilt out. Okay. So they're pretty straightforward and pretty common. Other things, well, I guess we talked about building integrated PV, and these are systems that are part of the structure, and a lot of those are more custom. We talked about a little bit, or specific panels that are intended for that purpose, and that's usually done more through an engineer or architecture firm or something where they're designing it as part of the building structure. So it's less common for just your typical installer to go and do that, unless you're trying to be creative and do something on your own place. And yeah, I guess there are some examples in your book of these different. I have the older edition of the book here, so I'm not sure if it's the same images, but they have some awnings that are shading windows. I'm looking at page 264 in the previous edition of the book.
Oh, yeah. Looks like it's 284.
284?
Yeah, in this book.
Okay.
It's showing shingles, awnings, windows,
Yep.
skylights.
Yep. So, and then there are ground mounts, and there are ground mounted systems that are very similar to the roof mounted racking systems that have multiple points of attachment, or you'll put in footers in a beam and then you'll mount those panels on the beam, if or attachment bar of sorts. And then there are others that you mount on a single pole. And again, more examples of those. Something that's not as common anymore as was are the trackers. There are both computer-driven or motorized trackers that are programmed and run off a clock, essentially, to follow the sun throughout the year. And so they orient themselves using motors to guide the array throughout the
Does
day.
that happen throughout the day?
Mm-hmm. Yeah, so they would face to the east as the sun's coming up, and then they would follow the sun across the sky. And so they're maximizing performance throughout the whole day. And then there are others. There was one, ZoneWorks is a company that made a passive tracker that worked off of Freon. It had a tube on each side and a small, or a canister, more like a canister on each side, and a small tube that connected the two sides. And then they shaded the outside edges of the canisters, so when the sun shined across the panel, it would hit the canister on the opposite side and heat it up. It would vaporize the Freon, and so then it would push the Freon to the other canister. It was cool where it would condense. It would make the shaded side heavy, and so that would pull down the shaded side. And once the panel was oriented toward the sun, it would kind of equilibrate.
Okay.
So then as the sun came across, it would start heating the lower side more and start vaporizing that Freon and pushing it to the other side. It would condense and ever shift the balance so that it would passively follow the sun. No motors driving it is what I mean by passive. So it was really kind of a neat solution.
Yeah.
And no motors, no clocks, no timers, no electrical consumption at all. Just does its own thing. So those are pretty neat. Typically less expensive. The catch with trackers is they're more expensive than just mounting the system on a pole. They're more expensive. They incorporate moving parts and maintenance. So those are things to figure into the equation as well. And again, I kind of go back to these cost-benefit evaluations at every step. And what I've found, and I suggest that everybody do it on their own, is if you're considering using the tracker, think about what the added cost is of the tracker, and then say, okay, well, how much am I going to increase my performance by adding this tracker? Maybe 20%. What is it going to cost me to add 20% more solar panels to my array and gain the same amount of performance that way? And because the cost of solar panels has come down so much, my calculation comes out that you're way better off to put in a fixed mount and add panels. And so, but again, I think the trackers are really cool. I think it's neat and neat technology, but again, I suggest doing the cost-benefit evaluation because of the cost of the system, because of the added expense, and is it worth it? So often when we're assembling these systems, let me look at time and see how much more we need to cover here. And we were going to go back and touch on system sizing and so forth as well. Okay. So usually when we are putting up a system, especially here in Missoula, then we are required to have our structure evaluated for the additional load. Normally, a solar array is not going to add any more than another course of shingles, and if the structure is built to code within the past 30 years, it is adequate to hold another layer of shingles over the existing shingles, and so there shouldn't be any issue. But in Missoula, the city requires that we have a letter from an engineer stating that the structure is adequate. Most pre-manufactured trusses and truss systems are going to be up to code, and therefore they're going to hold the additional load. Older structures or custom-built structures may be closer to the limit, and so they might require a specific, evaluation. And sometimes we have to do improvements to the actual structure to bring it up to something that's adequate to hold the load of the solar panels. One of the things to consider is when we put a solar array on the roof, it's less weight overall than another course of shingles, but we aren't distributing that weight evenly across the whole roof. We're using mounting feet that are going to point load the structure underneath. So sometimes an engineer will say, yes, you can do it, but you have to have your mounting attachments have to be on every other truss. Your different rows have to be aligned differently, if you will, or things of that nature. So, and kind of in this picture, you can see those mounting feet, and those are going to bolt to something structural underneath, or you have to have some other means of attachment. Sometimes you'll be able to go into an attic or get below the roof surface and add structure or blocking to attach to. So I'm not following our pictures here very well, but here you can see these attachment feet, and so that's something that the engineer would do is make those calculations, or the solar installer, if they're qualified to do that, would make those calculations and see. And then we have things like the factors that have to be considered are wind loading and snow load. Wind is going to tend to either push down on the panels or lift up, so you have both effects. So you have to be able to have the array attached solidly to the roof, that it's not going to tear off in a windstorm or a hurricane if you're in Florida. And then here, more our concern is typically snow load, and are we going to crush the roof or cause damage to the roof by having snow piled on top of panels on top of the roof. So again, for liability's sake, I tend to always go back to the engineers and say, yeah, put your stamp on it. So, but industry-wise, there are some pretty established norms, and we've seen what works and doesn't work. One of the factors that we'll often look at is if we're screwing into the existing structure, if we're using lag screws and bolting, sometimes we through bolt. Truss manufacturers often don't want you bolting into their trusses because it weakens the truss, and therefore they want to see blocking between, maybe nailed or screwed between the trusses and attaching to that. And from the solar mount side, you'll either typically put a lag bolt through into the blocking to hold, or you'll through bolt it and have a nut on the bottom. Here is a different style where they're using a lot of smaller screws to try to attach to the decking. I haven't used it, and I don't know, it makes me a little leery. Lots of holes, and you're also relying on the sheathing to be your structural support. And if somebody, if it has particle board underneath, then I'm not going to be confident. If you have 3/4 inch plywood, then maybe, but still, it makes me nervous. I'd rather have something solid to connect to underneath. And in your book, it goes through what the withdrawal force of different lag attachment methods is, the size, and the depth of penetration. And again, if you have an engineer involved, they will often specify what that attachment has to be. You can be an informed installer and use your table in your book and look at those calculations and see if it makes sense. If they're suggesting something that seems far too weak or way overkill, then you can go back and ask, do I really need to use this, this large a screw? Typically, people use something else, and you can share that example with them. And if the person you're working with is commonly works on solar, then they're going to know what works in their area, and they're going to have that all lined out to begin with. But if you're working with somebody new or who hasn't done solar before, then you might get some things that are a little different, some ideas that might not be as efficient or otherwise. Again, in the book, it kind of goes through the different blocking options, lags versus through bolts versus a J bolt, which might be a good alternative on the pre-engineered trusses, so you're not actually penetrating the truss. One of the things that is important in solar, most of the racking is aluminum, and we typically use stainless steel hardware, and that's to prevent corrosion. Because if you use just the zinc plated, if it's in a very corrosive environment at all, then you'll start to get the corrosion of either the racking or the hardware. Typically the racking kind of crumbles, the aluminum degrades. And so here in Montana, we're really dry. We're not in a salty environment. You might be able to get away with just using kind of standard zinc coated steel, but I have not. I always use stainless steel, and that's my suggestion that you do.
I think about mine also. We want to do everything we can to make sure it's still waterproof.
And you have to look at the longevity of the system that you're putting in. I mean, if you're putting something in and you expect it to be there 40 years from now, go look in your garden and see what that bolt that was holding your fence together 40 years ago looks like. And is that gonna keep your solar panels on the roof 40 years from now? And in close contact with aluminum that whole time. So, yeah, if you lose the the galvanization or the zinc coating, then the metals start to degrade each other. So one important thing, and it's really easy to not do, is to coat. Let's see what they say this. There's an anti-seize paste that's easy to come by, easy to use, but it's another little thing that you have to do. A lot of times you'll get galling or little bits of aluminum stuck in the threads of your stainless steel, and it's like they fuse together. It's almost impossible to get them apart, and a lot of times you'll wring bolts off trying to separate them. So, yeah, if you ever have to go back and remove it, or if you put something on and you need to adjust it, or if you realize, oh my gosh, we forgot to plug in that cable under there, and then you go back to loosen something, and boink, you wring it off. And so having extra hardware on hand is important, and then using this paste is great, because it means that the system, the racking will come apart really easily in the future. And so it's a good habit to be in. I have a little jar of it with a little brush, and so I'll pull a bolt out, just hit it with the brush, and put things together and go. So it's a little extra work, but it's well worth it down the road when you have to take things apart. Let's see, if you do wind up doing a ground mount with a pole mount, you're probably going to have a engineer involved, or the manufacturer of the racking will give you engineering specifications on how it should be anchored or mounted, and so they'll specify how large a hole, what diameter, and what sort of ballast you'll need. And a lot of times it's astounding what's required in terms of the concrete footing for those pole mounts. So yeah, definitely do your homework on that and make sure that you have that factored into the cost calculations when you're going to look at that system. So, and that's about it for mechanical stuff. All these handouts are on the website, so you can look through them. If you have questions, shoot me an email. I'm not sure, is my email up? You have it, and Brad, I think he CC'd me on stuff to the class, so that should be available. And I will check emails this coming week over spring break if you have questions, and then we will meet again 10:30 Tuesday after spring break and go over electrical stuff, and if we have time, look at more of the sizing, the system sizing. So that's all for now. Have a good spring break. Recording work.